Let's talk about the laws that govern circuits and electricity within circuits. The first law we're going to talk about is Ohm's law. Ohm's law governs the relationship between the voltage drop across a resistor, its resistance, and the current that flows through the circuit, and it's related to the resistance of the resistor. So you can see the relationship here. V is equal to I times R. We can algebraically manipulate that equation to solve for I or solve for R, depending on what it is we're looking to solve for. But that is true for any circuit. Voltage drop across a resistor is equal to the current flowing times the resistance of that resistor. Kirchhoff's laws, the first of the Kirchhoff's laws that we're going to talk about is the voltage law. This means this voltage law states that the voltage increases, the batteries or the generators in a circuit have to be equal to the voltage decreases, the resistors or the lights or motors, whatever is dropping the voltage through a circuit as you go around the loop. So all the voltage increases have to equal all the voltage drops. Kirchhoff's current law states that the current going into a node or a junction has to equal the current going out. So I going into the junction circled here has to be equal to I1 plus I2. So what goes in has to come out. And similarly, we have going around the loop, I1 coming down and I2 coming down and I1 coming back into this second node at the bottom, and those add to equal I coming out of the bottom node. So let's go over an example. We're going to calculate the current in this circuit. We know that the battery is supplying a potential of 6 volts, and we know that the resistor has a resistance of 1200 ohms. So using you are going to use Ohm's law to figure out what the current is. Now we know that the battery is supplying 6 volts, so the voltage drop across the resistor has to be 6 volts because of the voltage law, Kirchhoff's voltage law. So we know now the voltage and the resistance, and we can calculate the current. So voltage is 6 volts, voltage drop across the resistor, divided by 1200 ohms, which is the resistance, and that gives us 0.005 amps, or 5 milliamps. Let's look at another example where we're going to use Kirchhoff's voltage law to calculate the voltage across the resistor. Now, we know that the voltage, again, the voltage rise has to equal the voltage drop. So the voltage supplied by our battery, which is 5 volts, has to equal the total drop the rest of the way around the circuit. The voltage drop across the diode and the voltage drop across the resistor. So a diode is basically a one-way resistor. It has a small resistance for current flowing one way and a very, very high resistance, so it doesn't allow current to flow backwards the other way. So our diode, we know, has a 12 volt drop across it. So what's the drop across the resistor? Well, we can calculate that using Kirchhoff's voltage law. Our supplied voltage, 5 volts, minus the drop from the diode, which is 2 volts, is equal to 3 volts. So we know our voltage drop across our resistor is going to be 3 volts. So we can now use this to calculate the current through the circuit. So current is equal to voltage over resistance, and because we now know the voltage drop across that resistor, which is 3 volts, divided by 300 ohms, which is our given resistance of our resistor, we get 0.01 amps, or 10 milliamps. Series resistor, based on Kirchhoff's voltage law, we can show which I'm not going to go through here, but we can show that resistors in series are additive. So the total resistance of these two resistors is equal to the sum of their individual resistances. So resistance total is equal to 600 ohms plus 1200 ohms, which is equal to 800 ohms. Now to calculate the current through the circuit, we know our voltage applied is 6 volts, so the voltage drop across the two resistors has to equal 6 volts. So we know that current is equal to 6 volts divided by the total of the two resistors, 1800 volts, gives us 3.3 milliamps. The power equation, the power in a circuit is how much work is being done by an element in the circuit. It could be something that is hooked up to the circuit, like you could hook a blender up to the circuit, or you could hook a light bulb up, or a resistor. And the power tells us how much work is being done by that element. Power is equal to voltage drop across the element times the current going through the circuit. And we can again algebraically manipulate this to calculate anything we want. Current is equal to P over V, or voltage is equal to power over current. So let's do a power example. Again, power is equal to voltage times current. Here we know that we have a 6-volt battery giving us a 5 milliamp current across a 1200 ohm resistor. So let's calculate the power. The power across the resistor is equal to the voltage drop, 6 volts, times the current, which is 0.005 amps, which gives us 30 milliwatts of power. So here's the worksheet summation of the laws that we talked about during this video. Ohm's law is V is equal to I times R. Voltage is equal to current times the resistance. The power law, power is equal to voltage times current, or P is equal to V times R. Excuse me, P is equal to V times I. And then we talked about Kirchhoff's voltage law, meaning that the increases in voltage have to equal the decreases in voltage as you go around any circuit loop. And Kirchhoff's current law, meaning that the current going into a node has to equal the current coming out of the node. And that is it for this video. See you in class.